Today we will learn about how to use regression to make simple predictions. In this lesson, we will learn to analyze the data and the role of data in machine learning, understanding the basic concepts of linear regression, what the least squares method is, and how it works to implement a regression model. Okay, let's get started. If you are Xiaoming, you want to buy a car for your family. To judge whether the price of the car is reasonable, Xiaoming needs to estimate the value of his favorite car in his mind. That is to say, you can use diverse parameters of the car, such as the width, weight, and power, to predict the reasonable price of his car. This is a typical prediction problem. Machine learning can use regression methods to solve the prediction problem of the price of a car. This can be achieved through the following 4 steps. First, we need to collect several known vehicle parameters and price data and process this data. Then, selecting an appropriate regression model, using existing data to train models. To make this model available for specific input, the predicted output is generally consistent with the data we collected. Next, we still need to collect some new data to evaluate whether the prediction is reliable. Finally, we have a reliable model. We can use this for real predictions. This process is a bit abstract. Let's see how it works. Data is the starting point of machine learning. We need to understand what data and data sets are. Data is a record that describes information about the object, such as the power, weight, and price of the vehicle. If there are multiple records, we have a set of data, also known as a dataset. Learning usually requires a lot of data. Collecting data is a time-consuming and labor-consuming process. Fortunately, there are many open-source databases on the web that can be used. For example, on Cargo, there are many good quality datasets uploaded by data scientists. As for web scraping, using this skill to extract data from websites legally is quite time-saving. The data in a dataset is usually written as a table. Each row is a data record. It is a description of a specific object, which can also be called a data sample. Each column of the table represents a feature, such as the power of the car and its weight. In particular, a column in the data will be that feature we want to predict, such as the price of the car. We mark it in blue. Our regression model will use other data in table columns and mark them in red to predict what is the value in the selling price column. As we mentioned earlier, different data is used to train and test the model. Typically, we split the data set. 80% of the data is used for training and the remaining 20% is used for testing. To visualize the data, next, we will use the method of data visualization to mark the data as dots on the axis. On the experimental platform, we will use different colors to mark the training and test data, respectively. However, we use the power and the price of the car as the x and y axis of a rectangular coordinate system, respectively. You can also run the code by yourself and see what you can get. Simple linear regression prediction exercise. First, load the dataset. Step 1. Load a car dataset. Extract the feature data power, car power, and target data price. Save them into a new variable, and output the first sets of data. Step 2. Split the dataset. Split the dataset into training set and test set. Set the parameter test size equals 0.2 and split the dataset at the ratio of 8:2. Specify the number of random seeds, such as random stays equal to 0, so that a fixed dataset split can be obtained each time. Step 3. Visualize the data. Visualize the training set and test set with different colored scatter plots. The data visualization is shown on the right side. Now, know that what data is. Let's take a look at how the model is trained. As we can see from the chart, there is a correlation between the price of the car and its power. The higher the power, the higher the price. We can call it a positive correlation. There is a line to draw the relationship between them. This is called a regression. Our training goal is to find the most suitable line. Of course, this line can be straight or curved. Different regression models were visualized by the shape lines. For the sake of simplicity, let's choose a straight line here as a linear regression model. We want to study how the power X affects the price Y. According to the analytical geometry, we know that a straight line is in a rectangular coordinate system can be described by equation y equals kx plus b. Here, k is a slope parameter. It is a number that describes and measures the direction and steepness of the line. B is an intercept, the point where the line across the y-axis. So, the goal of training can be turned into a data problem. We need to find the most suitable k and b, which are the regression coefficients. How to find the estimates of regression coefficients? Use the method of least squares. No matter how we put the line, it will not pass through all the data points. However, each line will have a different distance from all the data points. Here, we give the value of the sum of the squares of the arrows for each straight line in the graph. The least squares method is to find out which line with the smallest sum of the squares of the arrow. In this case, it's the red line. The distance from each actual value point to the line is different. That is to say, is this line used for prediction? There will be a different error between the predicted and actual values. It means that the smaller the total error, the stronger the prediction ability of this straight line. However, these predicted values minus actual values could be a positive or negative, and cannot be simply summed directly. Therefore, to conveniently count the total error, all errors can be squared and then summed all of the errors. The minimum value of this sum error indicates that it is appropriate right now. Although the calculation process is complicated, the scikit-learn library provides a fitting function for linear regression, which can help us to make it easier. It is straightforward to compute the k and b of the line. The relevant code is shown below. Finally, to evaluate the prediction effect of the model on the non-training data, we need to use the text data and recalculate the overall error of the model, MSE, mean squared error. is the mean of the squares of the errors, which assess the quality of predictors. We will not repeat the calculation here, since their calculation methods are very similar. On the experimental platform, we can experience how to achieve linear regression through least squares method based on data visualization, using the trained model to make predictions. 2. Train the model by the least squared method. Step 1. Determine the simple linear regression model. Step 2. Train the model by the least squared method. Step 3. Output the estimates of regression coefficients, the slope k, and the intercept b. Step 4. Visualize the model. Determine the coordinates of 2 points on the straight line model. And visualize the training data scatter points and the straight line model. Finally, the visualization of the model is shown on the right side figure. Three, test the model. Step 1. Predict the price with the trained model. Step 2. Calculate the mean squared error of the text set. Step 3. Visualize the text results. To visualize the training data and text data by means of the scatter, visualize the model by line and observe the test results. Now, the test results are shown on the right side figure. To summarize, in this lesson, we learned that a feature is used to describe the characteristic of an object. The second is to find a correlation in the sample data. If a straight line is used to describe the correlation, it is a linear regression. Thirdly, the least squares method is performed by finding the point to the appropriate parameter to minimize the sum of the squares of the errors.